Hi guys, I'm going to finish that lesson on Euler's method with that technology extension from the TI Inspire. So on my iPad, I know you can see the iPad right now, but I'm going to hit this TI Inspire right here, and it gives me a screen that's ready to be worked on, and I'm going to go to Graph Entry Edit, Differential Equation. And here's where we enter our differential equation, which is what they want us. Our differential equation on example number 4 is y minus 2x. And so I have to hold down the x and then move up to get a y. And they want us to do y1 minus 2x is what they've asked us to put in, and hit enter. And it's giving us that slope field. So it does give us a slope field. Now what we would like to do is we would like to put a point in so that we can see. We're going to put the point 1, 2 in so that we can see a function. Okay, so there is, we first had the slope field. Now we're looking at if we give it a point, where, what is that going to look like? So if it passes through the point 1, 2, what is it showing us? And what you can do here is, oh wait, I have to hit my function first. And then I can, I thought I could trace from there. I got to go back to tools. Here we go. And I can do a graph trace. And so notice that there is a point down here. And as I move along the arrow, it goes to, and it shows you those different points that it's hitting. And this gives pretty many points because we've got it set, I think, on 0.25, so every 0.25, oh no, it looks like it's on 0.1, because look, I'm going from 1.8 to 1.9 to 2.0, so it's every 0.1. You can change what that is on. I can take my graph trace off, and I can go and look at, if I tap on that, yep, our plot step here is 0.1, but we can change it to like 0.25 and see what that looks like, and see how they're further apart. And then if I want to graph trace, and I use my arrow to go from one to the other, they're going every 0.25. And there's not as many then, but these are points that, are making up the curve that goes through. Now, this is like moving along using Euler's method. If I take that off and go back to, let's see, this, look how it's using Euler's method. There's Runge-Kutta, which is another method, but we're doing a slope field, and I think someone talked about a directional field. Okay, it can't do a directional field, so it's just a little bit different. Okay, and then it also asked us to change the plot step again. So if I go to plot step, it said, what if you changed it, oops, sorry, I wanted to move that up. What if you, you're probably getting dizzy. What if you changed it to 0.5? And how does that affect your, and look how it really just kind of makes it such that you don't have as many of the points. And if you did graph trace here, oops, sorry, I didn't want to hit that. I wanted to do graph trace. If I do graph trace here, then you can see it is only going by 0.5s. And, it just doesn't give, I mean, it's fine, but you know, it doesn't give as many points. And then what if you made your plot step 0.05? That will give you a lot of points. And so, yeah, if you made it 0.05, look how many points it is. Oh my gosh. And it's giving you a point every 0.05 for x. But it does go through that point that we have listed here. So on our what happens when you edit the parameters, hopefully you can just say that, you know, it gives you more points, more of those values, so that you can get a better idea of what that graph would look like. All right, that's all I wanted to show you, just how your TI Inspire can give you a slope field.